Lights, camera,
Rolling.
Hello and welcome to another episode of the PRISM podcast on behalf of MMCOE Pune. I am your host Roma Shukla. Today we have with us Mr. Abhijit Patait, who is currently working as a Senior Director of Multimedia and AI Software at Nvidia. Mr. Patait completed his BE in Electronics and Telecommunication from COEP and his Masters in Electrical Engineering from the Missouri University of Science and Technology. He later completed his MBA from Haas School of Business, UC Berkeley, and now works at Nvidia. He leads the team that is responsible for video encoding and decoding, which is used in platforms such as YouTube, Netflix, and behind video conferencing tools. Welcome, sir, to the podcast.
Thank you for having me.
My first question to you is, sir, in your college years in Pune, you participated in many cultural activities such as Firodia Karandak or Purushottam Karandak. How did your experience in cultural activities shape the way you lead today?
Okay. So first of all, thank you for having me. So let's start from there. So there is certain connection between what I did then, almost 35 years ago now, and what I'm doing now. Most of the learnings there were related to teamwork, having taken initiative and then seeing the fruits of it later and not expecting something immediately. Yes. Looking at various ideas which are completely out of the box. So those are some of the things that I still continue doing while in general in life as well as my whatever day-to-day work. And how do they actually, how does that relate to all the cultural activities, right? So for example, in Firodia Purushottam, I was part of the musical team. I play violin, so I was a part of the musical team. And then, all 4 years we used to actually have many performances. And not only just Firodia Purushottam, but we had a group at that time called Bandareshmache, which actually was a Marathi music group. Had a large number of shows that we had done across Maharashtra. So a lot of those experiences, being in front of people, different people from different backgrounds and cultural backgrounds, and all across the Maharashtra or wherever. At that time it was limited to Pune and perhaps some parts of Maharashtra. And being able to communicate with them, have that interaction. Actually, a lot of those experiences have shaped me over time. Of course, the passion of music and passion of being a part of a very our core art of Indian classical music, Bharatiya, Hindustani Shastriya Sangeet, and being a part of that sadhana has actually made a difference in the sense that you have to be very, very consistent, you have to be disciplined, you have to actually learn from the right people and then follow certain guidance and guiding principles. I think that also has shaped me. So there are multiple aspects of it, and that a lot of those fundamental aspects of the personality shape what I am today and how I lead today in my life as well as in the career as well as personal life.
So as you said, you come from a very long musical background. So you founded TaalMala.com in, I think, the year 1999. So how was building software products back then different from as it is today?
Okay, interesting. So that was a completely personal experience. So after I graduated in 1996, I went to the US immediately, and at that time there were very few people everywhere who could even know Indian music, and particularly I was actually living in Florida at that time in the US, and there was absolutely nobody who could play tabla. And I as I said earlier, I am a violinist. I play in Hindustani Shastriya Sangeet violin on violin. And what happened is I needed tabla accompaniment. I mean, of course, for my daily riyas, for once in a while, even performances, I needed somebody to play tabla with me. And there was nobody. There's just nobody available, right? Nowadays, actually, you can get tabla players almost in every city in the US, but that was not back then. I'm talking about 97, 98. And at that time, software was very rudimentary. Windows 95 had just come into existence. There was a equivalent version on the enterprise side called Windows NT. And these operating systems, the CPUs, all of the computing power was very limited. So I had an idea, just an idea, and as people say, need is the mother of all inventions. That basically what happened. I thought, okay, let me see if I can generate some tabla accompaniment using the computer, right? Even in early days at COEP, when I was at COEP, I had experimented with something called algorithmic musical composition. There was a professor here in Pune University, head of department, called Dr. Sahasrabuddhe, H.V. Sahasrabuddhe. You may be aware of him. He's a husband of famous singer Veena Sahasrabuddhe. She passed away a few years ago. But I had actually interacted with Dr. Sahasrabuddhe at that time on that topic of algorithmic musical composition. So this has been an interest or kind of a passion by the side for me. So anyway, at that time I thought, okay, let me actually try if I can build some software which can help me for my own riyas. And you may be aware there's a language called Visual Basic, and I was not even familiar with the language. I was completely C++ programmer, but it was easy to program. So I thought, okay, let me try a little bit. So I knew a few friends here in Pune who I requested, okay, can you please record a few basic sounds of tabla for me and send it to me. And then they did. Actually, they were actually generous and kind enough to do that. And then it just built side by side while I was working, and my work was in completely different area. But as an interest, I kept doing it, and it turned out to be a reasonably good software which I could use myself. Okay, by 1999, I had a fairly decent software which was a simple dialog box. You press play, you select a taal, and then it will play that taal. That's all it was. And then eventually, I showed it to a couple of fellow musicians who were there in that area. And they said, this is fantastic, why don't you actually try to, see if others are interested and make it commercial. And one thing led to another. I mean, then, eventually the compute power on the CPUs, on the systems also started increasing. I got interested in it. Then I started adding more instruments to it, like, not only taal instruments, but also the, melody instruments. And then eventually it grew quite well. And it was completely on the side I was doing. I had a couple of people who were helping me here and there in Pune and elsewhere. But it was primarily a side, you call it a side activity, which actually turned out to be a reasonably good, venture. I wouldn't even call it a venture, but I think it gives me a satisfaction of building something for myself and having it useful for other people. Now there are actually tens of thousands of people who are using it daily for their riyas or their even performances. And, more than 70-80% of them are actually paid customers. It's actually a self-sustaining business now. I don't actually do anything. Now, I don't do it as a business, but there are, of course, to continue on this thing, I have to have certain amount of, return coming out of it. So that's not a primary purpose, but it actually also gives you the satisfaction of building something, right? So, I mean, that's basically the journey. Now looking at it in hindsight, 30 years is a long time. I mean, I still have the version of software I built on the first day, and it still works. Incidentally, Microsoft still supports the same version of Visual Basic, and it actually still works. But if I look at that code and what actually is there today in the software, I mean, it's day and night difference. And of course, right? I mean, it's completely different with the mobile platforms. It has completely changed. The complexity has changed. The ease of working has changed. Now, if I have to do it today all over again, I don't think I will write the software or I'll not ask anybody to write the software. I'll just give it to Codecs. I'll give it to Cloud. And then I think that will just be built, right? There's a lot of difference now. But again, of course, it's complete upheaval of how the software is built today.
Yes. So initially you started through the telecom industry from Motorola, Ericsson and HelloSoft, and then you shifted over to GPU. So how did you make that leap?
It was not an intentional leap, honestly. My my education, of course, the technical education, the engineering education. I mean, at COEP, I was in electronics and communication, so I was interested in communication theory and signal processing at that time. That is something that was near and dear to my heart at that point. And then in my masters as well in the US, I did most of the courses, and even my thesis was in wireless communication. At that time, you guys probably may not even be aware, there were no cell phones, and then there was no the cell phones, and there were some radios like police radios, what you call the public safety radios. Those were actually the only wireless devices that existed. But there was enough theory in terms of the books and the papers and things like that. So I used to read a lot. So my primary interest was in wireless communication, communication theory, information theory, all these kinds of topics. So, and I had that passion. Again, I'll speak about it later a little bit, but I think my passion was getting into research into wireless communication or communication theory. And that, incidentally, the opportunity came in Motorola and then eventually Ericsson. I left Motorola in a couple of years because of certain reasons. But those first couple of opportunities actually helped shape a lot of that thinking in that area, building the knowledge and building the technical knowledge and depth of knowledge. Multiple patents I had at that time, and it actually also helped. Many research papers came out of me, and I used to work a lot with the research team. My goal was to become a researcher in that area. Okay, I mean, long-term goal, at least at that time I used to think that. Eventually it didn't turn out to be that way, which is okay. I mean, all is fine. And then I kept working in that area, eventually in signal processing, in audio processing, some of the research related to voice over IP, which is again part of the communication, IP communication, all of that. But again, at a specific, something called a physical layer or a signal processing layer, or a lot of signal processing related codecs and audio processing or speech processing, speech synthesis, speech analysis, automatic speech recognition at that time, which used to be DSP based, all of those areas. In 2009, an opportunity just came my way to explore something new, and that was basically Nvidia. Nvidia was actually a fairly small company at that time. I was living in the Bay Area, San Francisco Bay Area, and I used to actually drive by Nvidia office almost every alternate day because it was on my way to my commute. And okay, it's a nice company. It's very well known, well respected, all of that. And then I thought, okay, I'll just make a switch, and it actually turned out, everything worked out. It was just something that I thought, okay, I needed a change, because throughout the period of all those years that I was working in signal processing and communication, I thought I needed a change, because once you start going too deep into certain areas, sometimes you feel, okay, it's actually, you need to learn something new, you need to expand the breadth, right? And that's how actually I got into Nvidia. And it was Nvidia at that time. GPU, nobody even knew about GPU. GPU was not a known term. It was just a graphics processing unit, right? Or, okay, something that to do with graphics, something to do with gaming, something that actually helps you, display your high-end graphics on your computer, right? Beyond that, there was nothing. And that was a completely new field. So I thought, okay, it'll actually help me expand my horizon in terms of knowledge and depth of various areas that I've been exposed to. So that's how I ended up in NVIDIA. There was no vision that NVIDIA will become this large at that time. And of course, nobody probably had that vision other than perhaps Jensen, who, at that time used to say that, okay, this is something that we are building. But, yeah.
So throughout the projects that you worked on in, say, communications or at NVIDIA, was there a particular moment that fundamentally shifted your perspective about technology?
That's an interesting question. I mean, there is not a single moment as such, a single project. There are multiple moments. One thing is that, see, there are a few things that shape you. As I was telling, my goal in the early years of my career was to become a researcher or gain in-depth knowledge of communication theory, information theory, perhaps do some groundbreaking research in that area. I kept working with a large number of people at Ericsson, Motorola, other companies, and really, really capable people. That taught me a lot. Okay. However, at certain point, I started realizing, this was around 2004-5. I started realizing that I can go into deep into certain areas. However, there are a large number of people who have gone into those depths far before I have, and I may not have the skill set necessarily to do something groundbreaking. I think that was a revelation, and I think every person has these revealing moments, right? At that point, I switched to breadth rather than depth. So there was a fundamental, shift in the mindset, that instead of actually starting to going into the depth of certain technology and certain, research area, let's expand the horizon. Let's look at various aspects of different technologies and start, building that base where you become, jack of all trades but king of none, sort of, right? And that kind of, shapes your thought process also. And because that thought process was built based on the experience that I had for last 7-8 years, which actually, I realized that, okay, I'm good at certain things, but, I would probably, it would be very hard for me to compete with people who have actually had, PhDs and postdocs in wireless communication and communication theory, and there's no point me doing that. I think it's just not, definitely going to scale. So at that point, I decided to move into management. I mean, it's not an easy decision, and I'll come to this in one of the later topics which we can discuss, but moving to management is not for everybody, right? It has its pros and cons, and more cons than pros. But I took that decision consciously and jumped into it and did that. Now that was one of the moments which fundamentally shifted how I looked at the technology, how I looked at what I'm doing on a daily basis. There was another incident which I wanted to specifically talk about is. After I went to Nvidia, in a couple of years, I started realizing that, okay, as I mentioned earlier, I was new to all these graphics. I had never worked in graphics, video, any of these technologies. And I started thinking, okay, I was learning. Of course, I was learning technologically. Managerially is a different story, but technologically, I was learning the technology that is being developed at Nvidia. But at the same time, again, the same thing hit my mind that, okay, there are thousands of employees who are there at Nvidia who actually have better knowledge than me. Where can I make a difference? How can I actually make a difference for myself and for the company? Both of those things. And there was one opportunity that came up. There was a very senior technical person at Nvidia who I was working with, and then he was building something which was being tested by a few customers, a few software vendors outside of Nvidia, and he was running alone. I mean, he was actually just he needed help. So I thought okay, why not help him? And then I had a few engineers who were actually working for me. So I thought, okay, I'll probably get one of those engineers help him and see because I saw promise in that technology. So I started proactively building that relationship with that person, and eventually over a period of next 6 to 8 months, we built that relationship, and that product eventually became a very big product. Again, I can't disclose a lot of details because of the confidentiality reasons, but that became a fundamentally very big product that had nothing to do with my core day-to-day work at Nvidia. It was a completely offshoot of a different technology, which I just was looking for opportunity, and it just hit there. Okay. Now there's a part of luck, there's a part of perseverance, there's part of some of my own initiatives, there's part of some of the motivation that I had to give to other engineers to work on something that they are not familiar with. All of that, right? And it was not groundbreaking. It was something that seemed very simple at the outset. But I had an intuition that this will actually be a hit with customers. So, being with those customers, talking to them independently, regardless of whatever is happening on your day-to-day job, or at least managing that, and in addition to that, doing some extra work, and getting those interactions, understanding what the customers would need, how I could shape that product on my own, without a lot of support from the rest of the management. I think all of those things taught me a lot. Again, coming back to your question, what caused the shift, how I look at the technology? I think there's a fundamental learning here. You don't need to invent groundbreaking technology to be successful. You don't. There are a lot of people, a lot of success stories you hear about groundbreaking inventions, but you do not need to do that. All you need essentially is, if you think there is a need somewhere within your customer base, within your people who you interact with, professional people typically I'm talking about, and if you can sense a combination of a few things that is your skill, your peer skill, your people surrounding you, your skill, and then somebody who is knowledgeable enough who can actually guide you, you can build something of value. You really can build something of value, and then you have to pivot at the right point. Pivot in the sense you have to be flexible. If a customer actually says, okay, this is actually not useful for me, but can you do it this way? That sentence is extremely important. Can you do it this way? You never say, oh, but this is going to take actually a lot of time. This is actually not possible. No, don't be a yes man or yes person. Say, okay, let me think. And think out of the box.
Open.
You have to be open, you have to be flexible, and then kind of pivot quickly and see how you can get it done. I think that is the fundamental shift that happened in my mind, and that has actually continued even to date. And hopefully I answered your question. Long answer, but yeah.
So as you said, you had a very deep engineering background, then you moved into managerial role. So and as you said, there are many cons in that. So students who know where they want to go in management, so what should they build right from now as to ease or lessen the cons?
What I consider management, there are multiple aspects. One is people management, which is the most known and most understood by students. And that is the hardest. Okay. Fortunately or unfortunately, when I got into that role, I adjusted pretty quickly. The other parts of management, project management, very interesting role. There is something called product management, very interesting role. There is marketing management, very interesting role. Sales management, very interesting role. All of these are types of management, right? In one you are managing technology, another you are managing the product itself, in other you are managing accounts of the customers and trying to actually get more and more sales. In certain cases you are trying to get more business. Each of these has a different pros and cons. Okay, and I don't think I can. It's not possible to generalize it. So I think your question was specifically with respect to people management, and I will try to answer it from that perspective first, and I'll try to touch upon a few other aspects of management. I don't think you can aspire to be a people manager getting out of college. You cannot. Okay, and you shouldn't. There is a fundamental reason behind it. Not everybody is good with people, and you only realize it after having worked with a large number of people from different backgrounds. And are you able to deal with them and make them do work for you or for your company or for your initiative, I would rather call it that way, without a lot of resistance, and in best case with a lot of passion coming from them. And that's when you become successful, because they are uplifting you, or they are uplifting the initiative that you are driving, right? This is not easy. This requires certain skill set which is fundamentally mindset change. And you'll only realize it when you've worked with a large number of people, because if you suddenly become a manager of people, you will be looked upon as a boss. You don't want to be looked upon as a boss. Never, right? When you want to be a manager, you want to be looked upon as somebody who is helping the engineers or helping the people who are working for you in getting their job done without taking the credit. This is very hard. I, as a leader, I was a manager. Now I'm in the leadership role. But we look at people, and there is absolutely nothing. Everything that they do, is the credit goes to them. And there's absolutely nothing that actually says, okay, Abhijit did this. At some point, somewhere, somebody says, okay, Abhijit's team actually delivered on this, or got this particular technology implemented, or whatever, right? But you have to make sure that the credit goes to the people and then genuinely that has to come from inside, and that fundamental mindset. And then once they realize it, they'll actually start working for you. And this actually takes time. This takes a mentality that they have to feel that confidence with you, and that cannot happen suddenly. So it is actually a people-centric role, very, very people-centric role. And once you have people-centric role, that people-centric role has many things which brings emotions from different people behave different way. They have differing priorities in their personal lives, in their professional lives. They have likings, dislikings, they have conflicts with others. You have to be able to resolve them in a very, very mutually acceptable way. You can never be forceful in these kinds of situations. If you start being bossy, that's the end of your managerial role, right? Or people leadership role. And that's similar, exactly same concept. So these are the cons. I mean, there are pros, of course. Pros meaning that you actually get to your contributions to the initiative's success or the company's success get multiplied by the number of people who are doing that work for you. So that definitely it's multiplicative in that sense. But there are cons in that you have to learn a lot of things. Now in other areas like project management, product management, similar concepts apply. But instead of people, you are actually looking at a particular product, how the product actually is looking. A customer is looking at those products, and then what would it take for them to adopt it so that it generates revenue for the company. In marketing management, you are actually looking at how can I be successful, or how can I market this particular product or a technology, or maybe a simple maybe a pressure cooker, right? And how do I actually make it appealing to the customers, and then how do I message it correctly? So there are principles of that, and that managing those principles with again the emotions of the people, or emotions of the customers, or emotions of the market in general, sensing that and understanding that and adapting yourself. So there's no science here. This is actually more art than a science, and that's why I think there is the students like you who are aspiring to be managers. It's actually a wrong thing. Try to get into area which actually gives you sufficient exposure to the number of things that you want to do. For example, if you aspire to be people manager at some point, yes, get into a company or get into an employment or start your own business where you get exposed to a large number of people and you kind of align them in the single direction. If you want to be a product manager, try to see what are the different products doing and how they're being successful in the market, and try to learn that. I think that is the thing that you should actually be looking at.
Definitely. Sir, so currently, what does your team at Nvidia do?
Okay, so I think you mentioned it earlier. That my organization is generally responsible. I'm person in charge for all the video and audio technologies at Nvidia. So that's why I said multimedia, and I think that you mentioned. There's a concept in Nvidia called person in charge, or pilot in command. That's what it's called as well. Many companies have this methodology, but basically. At the end of the day, many of the technologies that are related to video processing, video encoding, decoding, and that includes everything from building the software for the silicon that we actually develop, all the way to the applications and the algorithms that actually go onto it. Then AI algorithms, traditional legacy signal processing, image processing based algorithms, video post processing, all of that. So my organization builds that, and it's eventually responsible for that. When I say responsible, there's a large number of things, which is right from building and maintaining the software to interacting with customers and making sure that it gets into hands of the users at the end of the day. So that's the video side, and there is similar work on the audio side as well. Say a lot of audio processing. Again, there is a lot of silicon accelerators or hardware accelerators on our chips, Nvidia chips, which actually do a lot of audio processing. So managing all of that and building software for it, drivers, SDKs, so software development kits, APIs, even high-level interfaces, and then eventually supporting all the customers and all of that, right? And in parallel now, last few years, we have been involved in converting that into AI-based algorithms, because at the end of the day, Nvidia is all about AI. A lot of the world is moving in that direction. So I think a lot of that development is AI-centric now. So that's the fundamental, responsibility at a high level. So I'm person in charge for video and audio technologies. Besides that, there are a few support teams which kind of are required as a part of the support infrastructure for multiple software organizations. So I lead some of those initiatives as well. But the fundamentally is video and audio technologies.
So you basically work in video encoding and decoding. Many people of my age, students or many people don't really have an idea what a codec is. So how will you explain about codecs?
Okay. I think if you don't know what a codec is, best to take a course in video coding. Okay. I mean, that technology has evolved over last 25-30 years almost. Again, more than that. In fact, MPEG, I think MPEG 2 came in perhaps in early late 90s sometime when I was in college. I don't think I can explain codec in 5 minutes. I cannot. But essentially, it's a way of representing the information in a compact way, right? Because you can't. The information that you actually see, whatever you are seeing with your eyes or whatever you are seeing through your camera, that needs to be compressed, because that information, there's tremendous amount of information. If you just look at, certain amount of information is useful and certain information is not useful. So these codecs try to actually dissect it into useful information, not useful information, and they actually try to compress the non-useful information more and useful information less, and so on and so forth, and such that the amount of information that is transmitted is controlled. And this has been a proven technology. Codecs have evolved a lot in last 30 years. In fact, to the extent now that there are also initiatives across the world to make codecs themselves AI-based. So traditional codecs actually use a lot of image processing and block-based processing, something that we call block-based processing in video. But now, because of the DNNs, the deep neural networks, you can look at the content of the image or content of the video and figure out, okay, in this video, my face is important, or this particular tree is important, or most of the people will look at this tree. So why don't I actually enhance that particular aspect of the video and then keep the rest less important and give less importance to it, and then compress that more and compress that less, things like that, right? So I hope I answered your question.
Yes, okay. Yes. So, sir, as far as I have read, H.264 is a older, I think in the early 2000s. So it is an older technology, but in 2026, still majority of the internet's videos are using H.264.
Yes.
So why is that the case, and why are newer codecs or newer technologies, why were they not able to replace H.264 completely?
Okay. They will replace eventually. It's just taking longer. H.264 has been in existence for a long time. It was very successful primarily because it gave really, really good quality of compression. Well, very high compression at a very, very good quality. It was one of the first codecs which also supported a large, very large resolutions, a lot of video explosion also, which happened in the last decade from 2010 to 2020. That explosion also, many of those videos got encoded into H.264, and the companies like YouTube, Hulu, Vimeo, many of these companies, they encoded all those videos using H.264. because that was the codec of that was most advanced at that time. It had very good quality at very good compression ratios. So given all of this, there is a very large established base of the content in H.264. So for example, if you go to YouTube and if you ask YouTube by certain things that I've read, YouTube has literally trillions of hours of video footage, right? But then what is if they have to, a lot of that was developed in the first maybe 12 years, right? From 2005 to 2017, 18. Now, it was all encoded in H.264 because there was nothing that existed beyond H.264 at that time. And that has been archived, that has been stored. It has been, a lot of that actually doesn't ever get played. By one statistic, only 2% of YouTube's videos have more than 100 views, right? Something like that. Now, but the rest of the videos are still archived and kept. Now, you could actually convert those into more modern codecs, but it's a waste of compute power. Sometimes these companies look at it as a waste of compute power because storage is cheap. Compute power is expensive. Compute is expensive. So in order to convert from H.264 to the latest codecs, it doesn't make sense because if those videos are never going to be watched, but they still need to be there for archival reasons or for some historical reasons, let it be there. That's okay. Storage is cheap. Whereas on most of the newer videos that are being shot or uploaded, more modern codecs are being used. So for example, now YouTube also has started storing things in AV1, which is one of the latest codecs. Even Netflix actually has, to my knowledge, they have adopted AV1, if I'm not mistaken. But converting all of the legacy footage into the new codecs is computationally very expensive, and that investment of compute is perhaps not well worth it. Rather than that, it's okay to store it. So having said that, there is also another side of it, which is cameras. So for example, cameras a lot of times only encode your mobile phones. They, until a few years ago, they used to just encode using H.264, and then you would just upload it into YouTube, and you will just ingest it and then keep it, right? They wouldn't transcode it. They wouldn't change it to another format. There is no reason for them to do that unless they find that this video is going to be viral, it's going to be played millions of times, and at which point bandwidth becomes extremely costly for them. Because if they have to serve that video to million users, bandwidth becomes a major factor for as a cost factor. And at that point they will start actually thinking about converting that video into more modern formats which are bandwidth friendly or more compressed. So there are a lot of factors, primarily cost driven, and then technology driven. The endpoints have to also evolve. The whole ecosystem has to evolve. H.264 remained in existence and popular for a very long time, almost 15-17 years. And that actually built a substantial base of cameras, endpoints, the storage that already exists, the data center based video processing equipment which can actually process these videos. All of that can support H.264 as the basic format, and that's why it actually has stuck, and it will continue to be there. For my gut feelings is that it will still continue to be there, and eventually it will get it'll taper off, but I think there's still time for that to happen.
So Nvidia has always been open sourcing a lot of its tools. So what is the thought behind giving it away than keeping it proprietary?
There are certain things that are open source. There are certain things that are not open sourced. I think from outside, I think people just generally see that things that are open source, but our customers do not necessarily see that, right? I mean, and if you're a customer of Nvidia, they'll say that okay, we don't do enough. There's that thought process as well. But again, that's a perception aspect. I mean, I don't want to get into that because of confidentiality reasons. But in general, I'll answer that question in general rather than being more Nvidia centric. Open sourcing helps in certain aspects where the community development of that particular tool or that particular algorithm or that particular technology can be done by people who come from multiple backgrounds, from multiple geographies, in their spare time and whenever they get a chance, or people generally who are passionate about certain things, they come together and build something. That is far better than a certain company forcing a certain number of people within that company doing that, because it becomes then an initiative that may or may not align with those people's initiatives. But open sourcing actually helps in a way where most people who will contribute to it, they'll be generally passionate about it. You wouldn't go and contribute to an open source project unless you really feel passionate about it, that you have knowledge about it, and at the same time you really think that this should be done.
Yes.
And when 5, 10, 15 such people come together, imagine the positive reinforcement that it actually brings, and that actually has a multiplicative effect. That is why generally open sourcing helps, in the sense these projects become very successful. Not all of them become successful, but many of them become successful. The downside of it, of course, is that there is no revenue associated with it. At the end of the day, my firm belief is that software also has to be treated similar to hardware, in the sense that there has to be some revenue coming out of it. There has to be some monetary compensation coming out of it, because it is still engineering hours, it is still people's brain power, it is still requires effort, and sometimes far more effort than hardware designs. This is debatable, but again, and that belief exists in many industries. So although I'm actually proponent of open source in certain aspects for improving the quality of a product or getting something done through a passionate group of people, open sourcing doesn't necessarily result into the revenue models that actually can be sustainable in the long term. On certain products, they have been sustainable because people have taken those open source projects and built some closed source or proprietary projects out of it, and then selling those projects. But that's not necessarily always possible because of legal constraints and licensing constraints. So it actually creates challenges in that sense. So some companies actually, you hardly see very, very, very successful companies or successful businesses built on open source projects. That is because there's no revenue associated with it. And to sustain any software development, to sustain technology development in software, you need to have revenue. You need to have some monetary compensation coming in, and that is why I fundamentally believe that it is necessary. Nvidia, coming back to your original question, the Nvidia does both the open source as well as proprietary. The natural reason for that I can think of, again, I'll look at it from outside point of view. I will not actually disclose anything proprietary, but a natural way of looking at, most companies do this because they believe that certain technology, if they open source it, that will again have multiplicative effect on certain parts of their perhaps revenue or reach to the customers and things like that. So for example, again, not in Nvidia context, a certain company believes that it's, some software is developed, and that software actually eventually, if it's built and enhanced, it will feed back into some of the products that they have, proprietary products, which they can incorporate back and sell as a proprietary software. And a lot of times that actually does happen. And then that's also one of the motivations. Sometimes motivation is completely very, very philanthropist and then just give it away, and that is okay too, because world still needs certain technologies that need to be actually evangelized in that manner, right? So there is a spectrum of whole things there. So there's no single answer to it.
So you've built a Python library for video encoding decoding, I think. PyNV video codec. So what does that library actually do? And as far as I know, C and CPP are more preferred for GPU programming. So what drove your decision in building it on Python?
Yeah, everything has been moving towards Python in last 8 to 10 years. and that shift started sometime in 2016-17, around that time frame. Python has been around for quite a while. I mean, in fact, I have experimented with Python in probably late 90s and in early 2000s. I remember it was a nice scripting language, but what happened is that shift started happening in 2016-17. Somehow a few projects started using Python as a language for programming various things, and that not necessarily GPUs, but it was easy to program, very type safe. A lot of things where possibility of crashing the system are almost zero, since it's a user mode programming model. A few other things that some of these frameworks that came in, like for example PyTorch, that came in for deep learning training and inference, that actually gave a huge boost to Python, right? So Python had started becoming useful around that time frame. Naturally, video processing is not a... People think that video processing or video encoding decoding in particular is not part of the deep learning workflows or AI workflows, so to say. Actually, that is very untrue, because if you think about it, and many people probably don't realize this, but video encoding decoding is a fundamental part of the processing pipeline or a processing chain that happens for DNN training or many of the technologies that actually use videos. A lot of, for example, video processing DNNs or video generation DNNs, AI, which is called Gen AI, generative AI models. They are trained on videos, and those videos need to be first decoded, because those videos are actually in the encoded format, and they need to be decoded before they are fed into the training pipeline. And that a lot of that actually is an extremely efficient processing that happens without wasting any of the compute that is on the silicon, because every drop of power that it matters actually, that it consumes. So our earlier technologies that were for video processing, all the software used to be in C++, all the APIs and everything, all the SDKs were C++ based, and that actually still exists, and that is continued to be the case. However, eventually when these workflows start mattering more, or these workflows start they have to be made efficient, and your customers, who are indirectly the researchers who are building these models, generative AI models or video processing models, they are actually saying that, okay, programming these things only in C and C++, where all of my rest of the model code and model training is in PyTorch and Python, doesn't make any sense, right? They have to actually do a lot of this juggling around between two languages, and then there are possibilities of making mistakes in C code, and then something can crash. C is not memory safe and all of that, right? There are a lot of problems with these low-level programmings. So I think that naturally had to be done in such a way that this becomes very user-friendly. Python was a natural choice there. So we had to build the bindings for Python. Again, this is not a very big project. It's one of the multiple tens of projects that are happening at Nvidia within particular video technologies. But this is actually, again, as I said, need is the mother of all inventions, right? This is not a groundbreaking invention, but there was a need. We foresaw a need, and that need had to be served, and that had to be served in timely manner, and then supported by Nvidia. Again, relating to your earlier question about open source, that particular library is open sourced. Yes. So which is actually that decision was consciously made, just in the sense that, okay, this is something that our customers, users would perhaps may want to make some changes, because whatever Nvidia does may not suit everybody's workflow and building that efficient pipeline. So some of those things they might have to modify and adapt to their own needs. So why not give them that flexibility? Because there is not necessarily a whole lot of IP that is going there. So it is okay to actually do that. So I think that some of these decisions are also based on this.
So Nvidia works on building platforms and the infrastructure rather than its own AI models. So what do you think about this bet?
That's a misconception. NVIDIA does build AI models, really state-of-the-art AI models. In case you're not aware, one of the most state-of-the-art physical AI models that NVIDIA has built is called Cosmos. It has been there for the last couple of years, and it is one of the most state-of-the-art models that is being used for autonomous vehicles, robotics, video analytics, in many use cases. There are multiple applications of it. Video generation, things like that. It also builds LLMs. NVIDIA has its own LLMs in Nemotron and things like that. NVIDIA also has video processing and audio processing models, which actually some of them are proprietary, some of them are open source, things like that. So NVIDIA does build models. However, you are absolutely right that it's a platform company. It's an infrastructure and platform company. The models are built primarily for two reasons. The company tries to strive to do something that is state of the art, which is, I would call, at the front of the wavefront of invention. I call it a wavefront of inventions. And to lead the way, what is possible on NVIDIA's platforms, a lot of times these models are built so that the customers or users or even researchers get inspired by that. Sometimes researchers also inspire NVIDIAns internally and say, okay, they have built something very interesting in this research paper, but I think that can be changed such that it becomes more efficient on NVIDIA hardware if we make certain changes in certain way, right? And then that gets built internally, and then that gets either open sourced or it becomes a proprietary model depending on all the licensing conditions, and it eventually becomes a product. So there are all sorts of things that are happening. It gets known as a platform and infrastructure company because a large part of financials and revenue is coming from there naturally, and that is there's no doubt about that, right? There is there may be revenue coming. Again, I can't disclose that, but there may be revenue coming from software as well, and certainly but it's not as substantial as you would see. Like this quarter was $81 billion revenue. Out of that, a very small part of it could be from software. So it's not known for that. But again, to show the customers and researchers what is possible with NVIDIA's hardware, what is possible with our platforms, what can be done. And also a lot of for example, the Cosmos model that I talked about, it's open sourced. It's actually open model. So anybody can take it and build something on their own from this. So that's great, right? So it is, but it works on NVIDIA hardware, and then it shows how to run something efficiently like that on the NVIDIA hardware. And that actually is a significant value for all the customers as well as NVIDIA, right?
So, sir, there is always a rising demand for compute, and model sizes also keep growing. So when you start building today for something, say, that is due in the next 2 years or 4 years, so how do you build or how do you plan a hardware roadmap for it?
This is a generic question. You will have a vision, and that's this. I will not answer this from NVIDIA's centric way. I'll just generally answer this question. For building anything, generally you will have a vision. You will have some way of, okay, I want to, this is your thought and this is how it is going to look like today. Certain thought will be there. It requires you, let's say 6 months, a year, maybe even 2 months, or maybe even 2 years or 4 years to build it. And typically in any silicon industry, NVIDIA included, it takes multiple years, 4 or 5 years to plan a silicon chip and then execute it to the point where it actually comes from the fab and then it actually starts working and then gets to a customer's hands, right? So how do you foresee what is going to be there in 2031 today or 2030? That is essentially your question. You can't. The simple answer is you can't. You have a vision, you have a certain conviction about where the technology is going to lead you, and then you start building based on that. But you plan based on that. Again, depending on what your horizon is, it could be 2 years, it could be 4 years, it could be 6 months. You plan based on that, but be ready to pivot at any time. And so what I mean by that is be very, very flexible. And that happens routinely in all the workplaces that I have worked at. It happens with varying degrees of success. Nvidia is one of the companies where I have seen this happening very consistently with almost 100% success. Jensen has been a visionary leader for us, but he has built the company, and a lot of us old timers have actually helped, to our with our ways of doing it. That if there is a certain change that needs to happen in the plan, the entire company can pivot behind that change, and then we can actually make that happen. And this is not easy now Nvidia has grown large enough for such changes to happen, but it still happens. Many companies I have seen worked in the past, it doesn't necessarily happen very easily. So this is actually the key. If you see, for example, I'll give you a very simple example. Again, this is a hypothetical example, but still relatable. You have certain software that you're planning to build. Let's say a DNN model that you're planning to build for doing something, some generating, let's say a cartoon or anime or whatever, right? That for a particular type of style, and you're building that. What happens is that you can actually continue to build it in silos and then get to a finish line, let's say in 6 months, 8 months, a year. You'll have spent all the compute, all the efforts, all the brain power in doing that. You build something, and now you're looking for customers, or you're looking for somebody to adopt it. Because at the end of the day, just building and getting that satisfaction is not your goal. Somebody has to be able to use it so that you actually get a satisfaction. Okay, somebody else is using my technology that I built. But you go to somebody and say, okay, this is useful for me. It looks good. I can use it in my movie, for example. They're building, getting a movie done. I can use it for generating some of the scenes. But it would be good if some of the clothing on this anime characters that you are actually doing had a feeling of maybe Indianness, or maybe it is some different culture or something like that. Now for that, if you start building, if you start getting that feedback at the end of that 1 year, you have a problem. You wasted that 1 year. Instead of that, continue getting that feedback as you go through that process. And because if you find somebody who's an adopter, who's an early adopter, who's going to be an adopter, better to get that person or the entity involved early, get that feedback, be flexible to change it at the right moment, so that whenever your product is built, your DNN is built in this particular example, you are able to that entity is able to use it immediately, right? So that, and then being able to pivot that, be flexible, and receive that feedback, and understand that their feedback is the most important, regardless of your capabilities. You may not have the capability to change in the way that they suggested, but if that you have to say that, okay, this is what they need. So hence I have to find out ways to do it. No matter what, I have to find ways to do it. And that actually helps generally. And that is how most successful organizations lead their way through this uncertainty. There is uncertainty everywhere. You cannot foresee what is going to happen in 3 years, 4 years, or even 6 months. Who knows, right? But there's more certainty for 6 months than 4 years, of course. But 4 years is a long period of time in this kind of industry. So that flexibility is important.
Sir, nowadays technical knowledge alone is not sufficient. You need to have a problem-solving intuition. So, what should students do who want to work in AI or hardware? How should they build that intuition?
Intuition cannot be taught. It cannot be taught. It is what it is. Honestly, you can actually develop it to a certain extent through experience. Some people have a natural intuition, and I think they generally do well in their early parts of their career. Some people learn it over a period of time, and then they also end up doing well over a period of time. You talked about AI and hardware. I think there's nothing specific about AI and hardware. I'm just generally answering this question from the intuition point of view. What needs to happen again, this is a general, my 2 cents advice to any student who is graduating in the next few years. Try to start looking at the bigger picture. When I say bigger picture, you might have interest in certain technologies, certain products, certain area of work, and it could be anything. It doesn't need to be technology related. It could be music. It could be actually movie making. It could be some creative art. It could be design. It could be engineering. It could be robotics. But start looking at the bigger picture. When I say bigger picture, instead of looking at, how do I build this computer vision algorithm? Again, my examples are all in that area, in that field, because I'm day in day out working in that field. But instead of building and thinking about an algorithm and a model that actually improves the performance or the quality of a certain computer vision based model or some video processing model or audio processing model, that is certainly important. But detach yourself from it for a moment, for every now and then. If you are building that, that's great. You should build it, and that's your focus. However, detach yourself from that work momentarily every now and then. Start looking at where is this going to be used? How is it going to be used in the end-to-end workflow of whoever is going to adopt this technology, or whoever is going to be adopting this product. When you detach yourself from there, you will start getting that intuition. Okay, if this is how it's going to be used, the piece that I'm building in that entire workflow is only 5% of the entire thing. So, is this actually me spending months and months of effort on optimizing it, or making it memory optimized, compute optimized? Is it actually worthwhile? Perhaps not. Let me look at the bigger picture. Where can I actually focus more? And that will give you the intuition as to what you should be focusing more. That gives you intuition as to what you might want to build as a skill set as an employee, if you are an employee, or if you're an entrepreneur, what would make sense to actually build next? That this is actually a bottleneck, that is a problem which most adopters or most workflows will run into. So let me actually work on an idea which have a fantastic idea to actually optimize that. But still don't lose the bigger picture, because then you'll start getting deeper into it. But still do not lose the sight of bigger picture, because that bottleneck might shift from this to another place in a year's time frame. So you have to keep that in the mind. So having that wider vision, the breadth of that vision, where you're not looking at only the depth of a particular small module, but looking at the bigger picture is important. That builds the intuition. It builds it over time. Again, I'm saying that this is not going to happen in one product life cycle, not 2 product life cycle. You'll have to go through multiple such product life cycles as an employee, as an engineer, as an individual contributor, perhaps as a manager or whatever it is, right? Your role or as an entrepreneur, to actually understand and build a product and talk to customers and all that. If you have gone through a few product life cycles like this, that intuition builds. Some people have it naturally, and they are the ones who become, Mark Zuckerbergs of the world, or Larry Pages of the world. But some people don't necessarily have it, but that can be built. I mean, for example, I will be very honest. I built it. I didn't have that intuition, so I built it over time. But it can be built. It is not impossible.
So what mistakes do you consistently see today's students make when they're trying to build a career in, say, any technology?
Okay, I think I touched upon it. Not looking at the bigger picture. Okay, so that is one of the most fundamental mistakes a lot of students do. If you really have the passion to go in depth of certain area, by all means do. I think that is absolutely okay. But but do not lose the sight of a bigger picture. When I say bigger picture, how is what I am building, or how is my area of interest, or my passionate area which I am working on, how does it fit into the larger picture? Is it only 1% of it, or is it 15% of it, or is it 50% of it? If you have that sense, you'll be able to make the right decisions in terms of where to focus on. You may still be interested in that area, but nobody may actually care once you have built something there. Once you have actually worked on that area, nobody may care enough. And then it might actually become a heartache for you. So that actually is one of the problems. Again, building that intuition will be, you will build that intuition if you start looking at the bigger picture naturally. So that is a mistake I see that a lot of people do. The second mistake I feel a lot of students do, but I think a lot of educational institutes have started correcting it or changing in that direction, is teaching students and also making them experienced in effective communication. Getting them talking in front of, explaining an idea in front of 50 people in a way which can be understood by the audience. And it's an art. It's not a science. This can be taught. Some people have it naturally again. Some people do. Most people do not. Particularly, I see this in Indian students in that context, because our schooling system, our overall educational system is not geared towards this. Again, I'm not blaming it. It is what it is, and it is fine. I mean, there are certain pros and cons, but this is one of the aspects that I see routinely. People are not able to explain in an effective manner, understanding what their audience wants. And that I see repeatedly in junior people, even senior people. I see it routinely, and this is an area that I also feel very close to, because I think it is important. If you are explaining an idea to somebody, even I don't know if I'm being effective when I'm speaking with you right now. I don't know if I'm able to convey my ideas. Right? I'm hopefully I've acquired that technique over a period of time. I was not actually that effective in the early parts of my career. I've acquired that over the period of time. Understanding what the audience is going to be and what they need, rather than actually, if I could use a lot of technical terms and very, very techie terms and acronyms. I call it TLAs. That itself is kind of 3-letter acronym, right? TLA. So I can use a lot of TLAs and proprietary terms, but you will not understand anything I said. That I think a lot of people make that mistake. Understand the audience and convey what you want to say in the simplest possible language, but yet be effective such that the core message is actually conveyed. That is the fundamental art of communication. I see a lot of PowerPoint slides, even at my workplace as well as elsewhere. People write stories on PowerPoint pages. Stories, literally stories. And once that comes up on the screen, what is it? I mean, audience gets confused, right? Should they be reading that, or should they be paying attention to the speaker? So my rule of thumb has been 3 bullet points, 5 words each, or 5 bullet points, 3 words each. If you want to have a textual slide, first of all, never have a textual slide as long as possible. But if you have to have it, 15 words is the limit. You split it 3 by 5 or 5 by 3. It doesn't matter, right? And I enforce it with the people who are reporting into me at Nvidia, and to an extent I enforce it, and it actually becomes effective, because then that person has to be able to choose the words carefully and the most effective words, and the rest of it is explained. And that actually is more effective than anything else. So again, as I said, you see where students make mistake. I'll come back to that. These are the two fundamental things: getting to understand the bigger picture, and conveying the ideas appropriately. This has nothing to do with technology. This is applicable everywhere. Okay, you could be in robotics, you could be in design, you could be in farming. Doesn't matter. You have to be able to understand, what is my biggest problem in farming today? Is it actually pesticide management, Is it fertilizers? Or is it choosing the right crop? Or is it something that is completely, maybe market conditions? What should I be focused on? I mean, I should be focused on everything. I want to do everything, of course, but how do I actually look at that bigger picture and see how to manage different things? Again, that goes back to the management principle also. What is the most important thing? What you should say no to and what you should say yes to? It also comes to that, right? So all of these, again, a lot of these come after experience, and that's why I think one of the first things I said, if you aspire to be a management professional in any management, you cannot be a management professional after getting out of college. You cannot. It requires having gone through a few cycles of this, and then you actually find your moat there.
So we started with Firodia and Purushottam, and it is definitely an experience that people remember throughout their lives. So what do you think should be the key takeaway of that experience?
You mean what was my takeaway from that for my journey, or what?
Yes.
I think I touched upon it in the origin answer to the first question you asked me. The Firodia Purushottam journey helped me understand basic principles of teamwork, hard work, perseverance, also failure, because in my 4 years of being at COEP in Firodia team, every year we were second. We never won the Karandak. Okay, so getting out of that, it's not a failure per se, but not having Karandak, and the previous batches were consistently winning the Karandaks, but our batch never did, right? Which is okay. I mean, but still, having gone through that experience, a lot of things where we did one of the very first experiments ever done on a theater. Having an experiment where real rain falls on a stage. I mean, in the first year of our Firodia, it was actually something that we thought, okay, we'll create. We created a kind of a perforated kind of a structure, which was hung up by some people at the top of the stage, and then they poured buckets of water in it so that the rain falls actually on the stage. That was an interesting innovation, but it required a lot of engineering thought. First artistic thought, then engineering thought, execution of it, getting it done on the stage at the right moment, all of these things, right? Again, I was to a certain extent involved, but some of those discussions, those brainstormings, that actually helped. A lot of that interaction helps, right? Being able to convey those ideas, being able to convey some of the artistic visions into what can be done. So for example, I was in music teams always. So if a certain particular musical piece, can we change it in this way so that this is more suitable for the rest of the things that are going on the stage at the time of Firodia Karandak's show, right? All those things, right? That thought process actually builds. Now, looking back at it, is there a direct relationship of that to what I'm doing today and how I'm working day to day today? It's very difficult to make that connection, honestly. It's a long time ago. It was 34 years ago, and I really don't, have sufficient brain power to think, okay, how does that relate to today's? But again, some of those seeds that were sown of these ways of working have actually continued, and definitely the music passion that I have had has continued throughout my that TaalMala experience, all the app and the software and all of that. Plus, a lot of my interest, passion about music has also translated into signal processing and audio, because a lot of times a lot of audio algorithms that we built, audio processing, speech processing, they're driven by my intuitive knowledge of how human ear perceives music, or what are the tonal qualities of speech, or what are the tonal things that you should be actually focused on when you're analyzing certain audio patterns and things like that. So it has also shaped some of that some of that thinking. So it's technologically it has been helpful, managerially it has been helpful, personally, it has been a rewarding journey, of course, and that's definitely the case. So yeah, I hope I answered your question.
So thank you so much. It was a really insightful conversation.
Sure. Thank you, Roma, and thank you for having me.